Have you ever pondered how Netflix recommends movies you might like, or how Google predicts what you're trying to search for? The answer lies in machine learning. Welcome to the fascinating world of machine learning, a realm where computers learn from experience, much like we humans do. But how does that happen, you ask? Well, machine learning is a subset of a larger field known as artificial intelligence. It's a science of getting computers to act by feeding them data and letting them learn for themselves. Intriguing, isn't it? Now, imagine teaching a child to identify an apple. You show them various pictures of apples until they can recognize one on their own. This is precisely what happens in machine learning. But instead of children, we have machines. And instead of apples, we have tons of data. The machines learn patterns and make decisions, getting better with each iteration, each experience. Let's take a familiar example, our good old friend Netflix. Ever noticed how it always seems to know what you'd love to watch next? That's machine learning at work. Netflix uses algorithms that sift through your viewing history, comparing it with millions of other users' histories to suggest what you might enjoy next. Similarly, Google, the search engine we can't live without, uses machine learning to predict your searches. As you type, Google is already predicting what you're looking for based on what you and others have searched for previously. It's like having a personal assistant who knows your preferences, isn't it? So, you might ask, how does machine learning work? Well, let's break it down into simple steps. First, let's think of machine learning as a process that's similar to how we humans learn. When we are learning something new, we gather information, analyze it, and then use our understanding to make decisions or predictions. Machine learning models do the same, but in a more systematic and mathematical way. Now, onto the first step of machine learning, the training phase. Here, the machine learning model is provided with a dataset. This dataset is like a textbook filled with information. It is made up of examples or instances that have both inputs and their corresponding outputs. The inputs could be anything from pictures of cats and dogs to measurements of flowers, while the outputs are the labels or answers that we want the model to predict. The model then studies this dataset, trying to identify patterns or relationships between the inputs and the outputs. It's like a student studying for an exam, trying to understand how different concepts are related. Once the model has learned these patterns, it moves on to the next phase, the testing phase. Here, the model is given new inputs, ones that it hasn't seen before. And just like a student taking an exam, the model uses what it has learned to predict the outputs for these new inputs. But the process doesn't stop there. The model's predictions are compared with the actual outputs. If it made any wrong predictions, it goes back to the training phase, studies the data again, and adjusts its understanding of the patterns. This cycle of learning, testing, and adjusting continues until the model's predictions are as accurate as possible. This is the core process of machine learning. It might seem complex, but remember, it's all about identifying patterns and using them to make predictions. And the best part? Once a machine learning model is trained, it can process vast amounts of data at incredible speeds, making it much more efficient than a human at certain tasks. In essence, machine learning is the art of teaching computers to do what comes naturally to humans, learn from experience. Did you know that there are different types of machine learning? Just like the multiple flavors of your favorite ice cream, machine learning also comes in various forms, each with its unique characteristics. The three primary types of machine learning are supervised learning, unsupervised learning, and reinforcement learning. Let's start with supervised learning. It's like learning to ride a bicycle with the supervision of a parent or a mentor. The learner, in this case the machine, is given a set of examples with correct answers, known as labeled data. The goal here is for the machine to learn the relationship between the input and the output and apply this learning to unseen data. A simple example is email spam filters. The machine is trained with emails tagged as spam and not spam, and it uses this learning to identify spam emails in the future. On the other hand, unsupervised learning is akin to a kid in a candy store left to explore on their own. The machine is presented with data that is not labeled, and it must find patterns and relationships in the data on its own. An everyday example is online shopping recommendations. The machine groups together customers with similar buying patterns and recommends products based on these patterns. Lastly, we have reinforcement learning, which is like training a pet. The machine learns by interacting with its environment and receiving rewards or penalties for its actions. It's all about trial and error and learning from past experiences. A classic example is a self-driving car. The machine learns to drive by making actions, receiving feedback from the environment, and adjusting its actions to maximize the reward, which is a safe and efficient drive. Each type of machine learning has its unique approach and application, making it a versatile tool in the world of technology. Just like how different flavors of ice cream cater to different taste buds, these types of machine learning cater to different data situations, making it a fascinating field to explore. Imagine you're in a car that's driving itself while you catch up on your favorite book. No, it's not a scene from a sci-fi movie. It's the reality of self-driving cars, made possible by machine learning. These cars are trained with millions of miles of driving data, enabling them to make decisions in real time, like when to change lanes or stop at a traffic light. Now, let's move to our homes. Ever asked Alexa or Siri to play your favorite song or set a reminder for a meeting? These virtual assistants use machine learning for voice recognition. They're trained to understand and interpret human speech so they can carry out your commands accurately. Machine learning also plays a crucial role in healthcare. It helps in diagnosing diseases by analyzing medical images. For instance, it can detect a tumor in an MRI scan that might be missed by the human eye. It's also used in drug discovery, helping scientists find new medicines faster. In the world of finance, machine learning algorithms are used to detect fraudulent transactions. They analyze patterns in spending behavior and can alert you if they detect something suspicious. This way, you can stay one step ahead of fraudsters. But machine learning is not just about high-tech gadgets or complex industries. It's also used in everyday things like email filtering. Ever wondered how your email service knows which emails are spam and which ones are not? Yes, you guessed it right. It's machine learning. It learns from the patterns of emails you mark as spam and improves its ability to filter out unwanted emails. The applications of machine learning are truly vast and varied. It's revolutionizing industries, making our lives easier and even saving lives. It's an exciting field that's constantly evolving, with new applications being discovered every day. Machine learning is not just a buzzword, it's a tool that's shaping the future, and we're just beginning to scratch the surface of its potential. From making our lives easier to revolutionizing industries, machine learning has a wide range of applications. So, what does the future hold for machine learning? Well, let's take a glimpse into the crystal ball. The potential of machine learning is vast, and it's set to revolutionize many aspects of our lives. From healthcare to environmental conservation and even to the far reaches of space exploration, machine learning is poised to make significant contributions. In the world of healthcare, machine learning could lead to more accurate diagnoses and personalized treatment plans. Imagine a world where algorithms can analyze medical images or genomic data, identify patterns that the human eye might miss, and predict a patient's risk of developing certain diseases. This would enable early intervention and more effective treatments, potentially saving countless lives. Turning to environmental conservation, machine learning could help monitor and protect our planet in ways we've never before imagined. Algorithms could analyze satellite images to track deforestation or predict the spread of wildfires. They could monitor wildlife populations and help us understand the impacts of climate change in real time. The possibilities are as vast as the ecosystems we're striving to protect, And let's not forget about space exploration. Machine learning could help us unravel the mysteries of the universe. Algorithms could analyze vast amounts of data from telescopes and space probes, identifying patterns and making predictions that could guide future missions. Who knows, machine learning might even play a role in finding extraterrestrial life. But the potential of machine learning isn't just in these grand, world-changing applications. It's also in the everyday technologies that we use. Machine learning can help create more personalized experiences. Think about your music streaming service that learns your musical tastes and suggests new songs you might like. Or your smartphone that recognizes your voice and responds to your commands. These experiences will only become more sophisticated and intuitive as machine learning continues to evolve. The future of machine learning is promising, with endless possibilities and innovations on the horizon. And while we can't predict exactly what the future will bring, one thing is certain: machine learning will play a significant role in shaping it.